I asked ChatGPT a couple of questions about differentiation. Not that many. I was able to go through the chapter of my self-study and weighted real analysis uh, without major difficulties, but I still wanted to get some information from ChatGPT as I was reading, and also after I solved a couple of problems, I wanted to know how close I got or if I did it correctly. So I asked it several questions about sinx, how to prove that sinx is continuous at zero. It gave me a very simple definition. Basically, the two-sided limit at zero exists. Then I asked for a more rigorous uh, proof, and here it went into a full delta epsilon proof, uh, going through the motions of the triangle inequality with sin x minus sine 0, getting to sine x. It shows delta equals epsilon, um, and then it continued with just a standard delta epsilon proof, but it also added some, and part of it used intervals near the end, which I found very instructional, so I like that. Then I asked for more rigor for extending the range, basically. So I said if it could do it for all real numbers. And here, ChatGPT um, did basically another continuity proof for sin x using delta epsilon. But then it went into using the terminology of Lipschitz constant 1. And that, I know it's in Bartle and Sherbert, but I wanted to ask more about that. And also, there was one of the formulas. I wanted to know more about the trick that it used, taking sin x minus sin a, adding plus and minus cosine a, which is equal to 0, and then getting x minus a taken out. Um, so I asked about that part of the proof, and it expanded on it. Uh, it went into more detail about how Lipschitz continuity is proven. Uh, Took notes from it. I hadn't seen this material, so found it very interesting. So this is an instance where ChatGPT is teaching me something. That's pretty good. That's good. So then I asked it for a Lipschitz continuity proof for sin x, uh, and it went about doing it. Very similar to a delta epsilon proof. Uh, it just assumes that it's equal to 1. Lipschitz constant 1. So it spit back the same trick that it had used before, but now a little different. A little different. So that was that. Then I was curious about how it would explain to me the whole business of going from continuity at a point to continuity for all reals. And it just went about describing uniform continuity, which is what I was expecting. And it goes about the whole business of Lipschitz continuity again. So I'm going to try to find me a better source that explains this material, and I'll learn from it. Then I asked it how to rigorously prove that sin x is differentiable, which I did correctly before looking this up. So I want to make sure that I don't have ChatGPT as my crutch, giving me a fish instead of teaching me how to fish. So by the time I went to ask it, I had already solved this problem very much this way. You just figure out a way to break out sin x plus h, and then that eventually leads to something that has cosine, and everything else cancels when you take the limit as h goes to 0. That's the way it's done. And yeah, got confirmation that it could do it, and I could do it as well, which is wonderful. Then I asked a more general question about continuity for an open interval, starting with continuity true at a point, and it described uniform continuity as well as just regular continuity. So that was good. A little bit repetitive there. I asked a repetitive question, got a repetitive answer. Nothing to see there. And then continuity for monotone functions, delta epsilon, proof again. Then I ended with asking, how do you prove a function is one-to-one? And this type of proof I have found elsewhere. I know it's used in number theory. You just you say, there's x1 and x2. You evaluate the function at x1. You evaluate it at x2. You subtract or otherwise prove that the only way for that equality to be true is for x1 and x2 to be equal. So there goes differentiation for ChatGPT for this cycle, this early cycle.